Alright, this is video 11, properties of definite integrals. So an integral, what is an integral? An integral is an exact way to find the area under the curve. So we can approximate area under the curve. This is to find an exact way. Okay, so the AP loves to ask questions about properties of integrals and manipulating them. It's a great question because you can definitely do it. So the first rule that we learn when we're talking about integrals is that the integral from a to a of any function, f of x we'll use for right now, dx, is always going to be 0. Because if I'm integrating from a point to another point that's the same point, then I didn't move, which means I have no area. So a to a is just going to be, or like 2 to 2, or 6 to 6, is just going to be equal to 0. That area is, there is no area because I'm not moving at all on my graph. Okay, next property. The integral from a to b of f of x dx. If a and b, I need a to be the smaller number. So if it's not the smaller number, then I have to switch my limits of integration. I'm going to put the b down here and the a up here. I'm still going to have everything else the same, but I'm going to make sure that I pull out a negative in front to symbolize that I switch those limits of integration. Next one is the integral from a to b of f of x dx can actually be integrated separately with a different point. So like if I have a c that's between a and b, so if a is less than c, which is less than b, then I can do the integral from a to c of f of x dx, and then I can add the integral from c to b of f of x dx. So I can break apart integrals and integrate each piece separately, and then it will give me my total integral, total area. Number 4. Number 4 is the integral from a to b of k, where k is a constant, of f of x dx. If there's a constant in your integral, you can just pull it outside. So you have k times the integral from a to b of f of x dx. It just means you can pull the constant outside. The fifth one is that integrals hold over addition. So the integral from a to b of f of x and subtraction, plus or minus g of x dx, is equal to the integral from a to b of f of x dx, plus or minus, whichever one you're doing, the integral from a to b of g of x dx. So it holds over addition and subtraction. You can break them up and integrate each thing in your polynomial, for example, separately, which is really helpful. And the sixth one is that they hold over inequalities. So I might need to move this up. The sixth one is that if f of x is less than or equal to g of x, so that means the function of f of x is underneath, basically, g of x. So for example, like on a graph, f of x would be here, and g of x would be here. Then that means that the integral from a to b of f of x dx is also less than or equal to the integral from a to b of g of x dx. Which makes sense, right? Because you're saying that the area under the curve of f of x is smaller than the area under the curve of g of x, which is true if g is always going to be above f. Okay, so those are your properties of integrals. Not something you need to memorize, but things to be aware of, like super aware of, is like when you're switching your limits of integration, you take out the negative. When you take the integral of the same limits of integration, it's 0. When you have a constant, you can pull it out in front of the integral. You can separate integrals, like for polynomials. That's really helpful. The rest, they're good to know, but you're definitely going to have to show that you know the ones I starred. Definitely. Alright, so here's an example. If the integral from 2 to 4 of x cubed dx is 60, the integral from 2 to 4 of x dx is equal to 6, and the integral from 2 to 4 of dx is equal to 2, find the integral from 2 to 4 of 1/2 x cubed minus 3x plus 2 dx. Now, we could do this by just finding the integral, because we do know how to do that by now, but we're going to use our properties to manipulate this instead. So we have the integral from 2 to 4. I'm going to first split it up. I have 1/2 x cubed minus dx minus the integral of 3x dx from 2 to 4.